Okay, students, can you hear me clearly? Students, can you hear me clearly? Please confirm with a message. Can you hear me clearly? Okay, nice. So today also I'm addressing a specific requirement, okay? I'm addressing a specific requirement because you have already gone to O-level classes, okay? So you know what is happening, what is in the science book and all. So you need my assistance on some specific scenarios, right? Okay. You need my assistance on some specific scenarios like this part, that part, some questions from this part, like that. So I'm addressing that kind of issues like mentioned by some students. Okay, so giving a small idea, we have done a series of English medium sessions and Sinhala medium sessions until now. All the sessions are available in our channel, our WhatsApp channel. Our WhatsApp channel will be again available in the YouTube live chat and in the Zoom chat and everywhere. Join our channel and WhatsApp group. So you can go to that WhatsApp channel. You can go to that WhatsApp channel and get all those resources, all those recordings. Okay, we did electromagnetics, electrical, power, hydrostatics, hydrodynamics. I can't remember. Electronics. We did lot of sessions. Okay, and we did a question session too. Lot of students participated in these sessions. Okay, so today also we are addressing few specific requests done by you, like electronics applications. A lot of students mentioned that that part is not clear, you can't understand that, and few other questions from our book. And we also have prepared a short notebook which you can use. Okay, a nice short notebook that you can use. It is also available in our WhatsApp channel. It covers all the physics parts, and there's some nice questions, and answers for those questions are also available. Okay, answers for those questions are also available. So everything you can get from our WhatsApp channel. And so that is the idea. So if someone don't know me, I'm Jan Dalilanand, an engineer and from University of Moratuwa, and again an A-level physics English medium and Sinhala medium tutor. Okay. So since a lot of requests were from English medium students, that's why I'm doing these sessions in English. Okay, this session in English, we'll see. So let's start with the session quickly. Okay. I'm going to cover the important parts first. I'm going to take time and cover the important parts first. And if you have some additional time, we'll do some questions, some additional questions in the additional time. Okay. So let's do it this way. And when do you guys have O levels? And when do we have to stop doing classes for you guys? There's that kind of a rule, right? I don't know whether that rule applies for online classes. And at the end of the day, we are doing it for free, I think. So we are not legally bound to do classes for you guys. We are not charging anything from you guys. So let's move forward. And are you ready for O levels? Yes, right? No big deal, right? People? So go to your I'll directly refer to your textbook, okay? Because a lot of students mention these issues directly referring to their textbook. We can't understand this page, we can't understand that page, mainly from electronics. All those pages were from electronics, okay? So I'll cover those areas. And one thing for sure, I'm not going to explain everything very clearly, okay? That means I'm an electronic engineer, so I know how these things happens actually. I can take 1,000 sessions and teach you this properly, but that's not the requirement at the moment. I'll teach it to an extent or to a level such that you can understand things to an enough amount. Okay, that is the idea. And one more thing is, we did an electronic session. We did an Sinhala medium electronic session and English medium electronic session explaining everything in the electronics part. Okay, so if you join or watch that session, this session will be more meaningful. Okay, because you would understand things more if you join that session, because like I think the students who join that session now understand electronics very well, so they will properly understand electronics applications. So if you are a student who didn't watch the electronics seminar, watch that at least after this session. You'll have a nice and absolute clarity. You'll have a nice and absolute clarity about how things happen. So what I'm going to do is I'm going to start from where we stopped that electronic seminar. Okay, we didn't dig deep into application, so I'm going to start from where we stopped. Okay, so we discussed everything in that seminar. Okay, we discussed everything in that seminar, and we learned how a transistor functions, right? We learned how a transistor functions. So I'm not going to explain how transistors function again. Okay, I'm not going to explain things again. Okay, I'm not going to explain how transistors function again, but what I'm going to do is I'm going to teach you the applications of these transistors and how these applications actually happen. Okay, so in that case, the first application is there on page 70. On page 70, if you see. So definitely watch the electronic session after this, because I'm referring to what I explained in that session. Okay, I'm referring to what I explained in that session. For the students who joined that session, now they have absolute clarity about electronics part, so they'll understand things better. Okay, so everyone please watch that session if you didn't watch that. Okay, so this is the transistor. This is the transistor. Okay, so this is a battery. This is a battery. We have a setup like this, and a bulb like this, and another battery like this. So this is the setup. Okay, so if you can remember from that electronic session that I did, okay, if you can remember from the electronic session that I did, and what I'm going to do is I'm going to quickly discuss these applications, then I'm going to move to our textbook. Okay, our short notebook. We discussed questions up to around page 45 or something like that. We discussed questions up to that point around page 45. So the questions after that, then I'll start discussing. After explaining this part, I'll start explaining the remaining questions in our textbook. Okay, so new students, refer to all these sessions, all the older sessions. You'll find them really useful. Okay, so now this is the idea. This is 3 volts. This is 3 volts. This is base. This is emitter. This is collector. So can you remember how a transistor functions? A small current goes in this junction. A small current goes in this junction. Based on that, a huge current goes through this path. Okay. But although we talk about current, what actually happens is electrons moving. Okay. Usually electrons moves in the opposite direction as current. Okay, why? Electrons are negative, so electrons move in the negative direction as current. Okay, so what actually happens was, okay, if you can remember, so to revise all the physics parts, I mean, go through our short notebook. Okay, it contains everything, so you can quickly go through our short notebook. It contains everything, so you can revise all the content really fast. Okay, so now what actually happened is current moves like this. That means actually electrons go like this. So if you can remember from my first session, what actually happened was lot of electrons arrive here. A small amount of electrons reach here. A large number of electrons move in this direction. Okay. So can you remember the example we got? Like this circuit controls the current. or the electron flow. That means when I make this point positive in a transistor, when I make this point positive, what happens is electrons are negative. Electrons are negative. So what happens is negative electrons always gets attracted to positive, right? So when I give a positive, see, I'm connecting the positive side of the battery to here, right? I'm connecting the positive side of the battery to here. When I make this side positive, due to that positivity, lot of electrons reach like this, okay? Lot of electrons reach like this, hoping to go in this direction. But what happens is, if you can remember, but what happens is, although this circuit calls the electrons like that, okay? Although this circuit calls the electrons like that, we are using a much stronger, properly understand, we are using a much stronger battery here, which gives a very high positivity to this side. It's a very high positivity, okay? So the idea is, we are giving a small positivity to this, okay? So seeing this positivity, seeing this positive charge, all the electrons start moving towards the transistor, okay? All the electrons start moving towards the transistor, hoping to go in this direction, okay? Clear? It's like bringing singers for political campaigns, okay? Sometimes people go for the political campaign not because they like the party held in the political campaign, just because they like the singer, okay? So here, electrons see this, so they reach here. They come like this. But then what happens is, those bodyguards and all, what they are going to do is, they are going to pull you into the political rally, right? So when you reach here, a very high positive charge is waiting here. A very high positive charge is waiting here, which will attract these electrons forcefully to this side. Okay? Here. So that's why we are providing a very high battery here, very strong battery here. So relative to this point, we are having a small battery here. So this point is a bit positive than this point. This point is a bit positive than this point. This point is very positive than this point. Extremely positive than this point. So what happens is, I mean, it's like this. If I try to like think about a very practical scenario, okay? If I try to think about a very practical scenario, I mean, I used the same example in the first electronics seminar. Like, now there's an event in your auditorium. The principal or the teacher in charge is waiting here. You don't see them. The prefects arrange a food table here. So you guys come here hoping free food. Okay. So that's what happens here. These electrons see a small positive charge here. So that gets attracted towards this side. They get attracted towards this side. Then the teacher in charge stays here and call you forcefully into the auditorium. There's an event in the auditorium, okay? There's an event in the auditorium. They forcefully put you into the auditorium. So these electrons come here hoping to go in this circuit. But this huge positivity attracts them. So everyone is forcefully pushed towards this side. Very few somehow manage to escape, okay, without the teacher being caught by the teacher. So very few are able to leave. Everyone else have to go to the auditorium now. So just like that, a lot of electrons reach here. Very few go to this side. A lot of electrons have to move to this side. But the deciding factor is, who decides how many students are coming to the auditorium. Is it the event or the food? It's the food, okay? It's the food. Who decides how many students are coming to the auditorium? It's the food. Then only this happens. The same way, who decides the current? Who decides the current? This guy. But this one receives a higher current. That means in this circuit, what happens is, based on this current happens. Based on this current happens. That means this current is controlled by this current. This electron flow is controlled by this electron flow. So as a result, they have a certain ratio. They have a certain ratio. That means if this side, if n number of electrons reach this side, sometimes 1000 into n or 100 into n number of students reach this side. Electrons reach this side. That means when n number of students escape, 100 into n number of students go into the auditorium, have to go into the auditorium. So there's a proportionality between them. There's a proportionality between the students who escape and the students who go to the auditorium. That means there's a proportionality between the current flowing in this circuit and current going in this circuit. There's a proportionality between the current going in this circuit and the current going in this circuit. So as a result, I can use the proportionality to control things. How can I control things? Assume that, I'll start with a better example. Assume that, the same example as I got in the first seminar, okay? Yes, base is controlling, yes. The same example as I got in the first seminar. So what are the electronic applications? So now I know that system is controlled by this circuit from the base, but according to that, a higher current goes through this circuit. According to that, a higher current goes through this circuit. Clear? So what I'm going to do is, see, now I'm speaking really slowly, okay? And we are in a huge hall. The hall can hear, everyone in the hall can hear what we are telling. How? There are speakers running everywhere, okay? There are speakers running everywhere. So I'm talking means I'm giving a very weak electrical signal. And I explained how the microphones work, how speakers work, how electromagnetic induction work in an electromagnetic seminar. Okay, we did a Sinhala and English electromagnetic seminar too. A Sinhala electromagnetic seminar and a English electromagnetic seminar. You can get everything from our channel. So students, WhatsApp channel is available in the YouTube, will be available in the YouTube live chat now, and is already available in the resources part. You can see in the resources part, you can see something called past recordings. You can click that and join our WhatsApp channel. There you can find our past resources, and even in our YouTube channel you can find them, tunes, answer scripts, everything. Okay, so join them. Okay, so now so I'm speaking very slowly, okay? I'm speaking very slowly. Because I'm too bored to speak such that everyone in the hall can hear. I'm speaking very slowly. Okay? So we are giving that signal here. We are giving that signal here. So current is controlled based on my signal here. Current is controlled based on my signal here. So what is current? Electrons moving in a certain pattern. So when I'm speaking, what is happening? Electrons move in a pattern according to my speaking pattern. Okay. Okay. I mean, how does my sound goes as a signal? Electrons move according to the pattern that I speak. Okay. So when I give that microphone signal to here, in this circuit, electrons move based on that pattern. So if n number of electrons are moving here, based on that pattern, 100 into n electrons are moving in this circuit. That means my sound goes here 100 times amplified. A very strong current goes in this path, so it goes through the speaker so everyone can hear. This is amplification. Okay, this is amplification. Clear? Because as I explained, so again to this example, what actually happens is, based on what is happening inside, sometimes we need more students, sometimes we need less students. So what we are going to do is we are going to change the amount of food available in this table. Okay, so when I increase, more students come, then more students go in. When I decrease the food, less number of students come in, so less number of students go here. So like that, based on the way I'm speaking, okay, based on the way I'm speaking, the number of electrons going in this path depends, but it's amplified. It's amplified. When one student goes here, 100 goes here. So if n number of electrons flow in this one, 100 into n number of electrons move in this path. So whatever I'm doing here is amplified and going in this circuit. Okay, whatever I'm doing in this circuit is amplified and going in this circuit. Okay, if it is 100, this is 100 into n. If this is n, this is 100 into n. So that is amplification. Okay, that is amplification. Clear? And something to remember, if electrons are moving in this direction, okay, if electrons are moving in this direction, current is moving in the opposite direction. Okay, why? Electrons means negative charges, so negative charges are opposite to the direction of current. So if electrons move in this direction, actual current moves in this direction. So what is happening is, based on the current pattern here, the current pattern here changes. Okay, more current in circuit means more amplified current in this circuit. Less current in this circuit means less amplified current in this circuit. If the current in this path is I, current in this path is 100I. Clear? If current in this path is I, current in this path is 100I. So whatever happening in this circuit is amplified and going in this circuit. Okay, clear? Whatever happens in this circuit gets amplified and it goes in this circuit. Okay, that's basically amplification. Okay, so go to this exercise. This is in your so it's available in your textbook, page 70. I'm not talking about a short notebook, your grade 11 textbook in electronics lesson. In page 70, you can see this practical. So okay, this is the circuit. Okay, this is the circuit. Yeah, this is an NPN transistor. Okay, this is an NPN transistor. If this line is going away, if this line is going away from the base, if this arrowhead is going away from the base, then it is NPN. Okay, then it is NPN if arrowhead goes away from the base. So now this is quite straightforward, okay? This is S1, this is S2, and they're asking S1, S2, and bulb L1, L2. Bulb L1, L2. So on means 1. So on means I'll call ON. Off means let's write on and off here. On means correct. Off means wrong. So if one thing is who's deciding the current, this guy. So if there is no food on this table, students won't come even when there is a concert or when there is no concert. If there is no food on this table, students will not come to the auditorium even though there is an event or even though there is not an event, okay? Student won't care. So in that case, if S1 is off, whether the S2 is on or whether the S2 is off doesn't matter. Okay? Whether the S2 is on or S2 is off doesn't matter. Both doesn't matter. If S1 is off, no current will flow in this circuit, okay? This path is broken. If S1 is open, open means switch is not on, off. If S1 is off, no current will flow in this path. So L1 is anyways off. And when S1 is off, even when S2 is on or off, L2 is going to be off, okay? L2 is going to be off anyways. Why? Who decides it? It's decided by S1. If there's food, if there is food, students will reach here. Then if there's an event, they will go here. Otherwise, they will leave. So what is the deciding factor? Food on the table. So if food is not there on the table, if S1 is off, no matter whether you have an open switch here or closed switch here, even though this switch is open or off or on, nobody cares. No electron will dare to go in this path, so they will not go in this path either. So when S1 is off, even when S2 is on or off, both, L2 is going to be off. Why? No one will reach the auditorium if there is no food on the base. Okay? Then when S1 is on, current goes in this path, okay? Current goes in this path. That means if S1 is on means there's food on this table. If there's food on this table, students will come anyway, even when there is an event or there is no event, okay? Nobody cares. When there is food here, students will anyways come, okay? So when this is on, anyways L1 is on, why? Students will come when there is food on the base. So L1 is on. But now if S2 is on means there's an event here. S2 is on means current can go in this path. S2 is on means current can go in this path. That means this circuit is on. That means there is an event here. So now anyways, since students are coming here, If there's an event, students will be dragged to this side. So as a result, L2 will have a current. L2 will have a current, so it will be on. It will be on. If S2 is off, if S2 is off, that means there is no current flow in this path. This path is off. This path is off. And this path is on. That means this path is on means there is food, but there is no event. When there is food here, but no event here, no students will go here, right? And even the principal won't call the students if there is no event here. So if there is no event here, students will reach here, take food and leave. Nobody goes into this side. So as a result, students will go only in this path. Current will flow only in this path. That means L1 is on, but L2 will be off if this is off. Clear? That's how things function, okay? Is that clear, everyone? Is that clear? Students, is that clear? Hope the examples are helping you. Okay, then what happens to the brightness? What happens to the brightness? Talking about the brightness, okay? Talking about the brightness, pay attention. Talking about the brightness, I mean, anyways, what actually happens is comparison of brightness. We have to compare the brightness only in this scenario, right? When both L1 and L2 is on. We have to compare the brightness only in this scenario when L1 and L2 is both on. So when L1 and L2 both on, okay, when L1 L2 both is on, we know lot of students reach the table to take food, very few leaves, many have to go to the auditorium. So many electrons go in this path, small number of electrons will go in this path. That means a small current will go through this bulb, a very high current will go through this bulb. So this one will have a very high intensity. This one will have a very high intensity. So the intensity of L2 will be higher when both are on. Clear? Intensity of L2 will be higher when both are on. Clear? Got the idea? That's how things function. Let's go to the next example. Page 71, signal amplifier, same story. Page 71, signal amplifier, same story. Here. So now you should be able to understand, okay? It's the same story, okay? Now it's quite easy, okay? It's the same story. Why? In a signal amplifier, what happens is we connect the signal here. We connect the signal here. That means based on this signal, current flow in this path happens. That means the amount of food is decided by this. According to that pattern, a huge current will flow here. Clear? So a very small current will go in this path. Okay? According to the signal, but proportionally to that, a very high current will go in this path. Clear? That means based on the signal pattern, electrons will flow, but many electrons will forcefully fall to this side due to this very high positive charge given by this battery. Due to this very high positive charge, many electrons that reach here will be forcefully dragged to this side. So this one decides the pattern, but that pattern will amplify and go in this circuit. So as a result, this speaker will sound according to this pattern. This circuit decides the pattern. That pattern amplifies it and goes in this circuit. That pattern amplifies and goes in this circuit, giving the same signal but amplified. That's what's happening in this hall. I'm speaking very slowly, but speakers are giving it to the hall, the entire hall. Clear? Did you understand? Mention in the chat, people. Mention in the chat. Put a message in the chat. Someone's asking the purpose. I mean that is the entire purpose. I need to speak slowly. I don't like to shout to the entire hall. I just need to speak slowly. I don't like to shout. But I need the entire hall to hear what I'm telling. So I need something that amplifies what I'm telling and release it. I need someone to amplify the exact same thing that I'm telling. I need someone to amplify the exact same thing I'm telling and give it to the entire hall. So that's the main purpose. Amplification. Clear? What is the purpose of this second battery? Why? To electrons go in this circuit. Someone should forcefully drag them to this side. For that to happen, there must be a very high positive charge here. Only a very high positive charge can attract electrons forcefully. Only a very high positive charge can attract electrons forcefully. So to create that very high positive charge, we have that battery here. So this is the positive side of the battery. So this positive side creates a very high positive charge here, which forcefully attract these electrons that hoping to go in this circuit. Clear? Got the idea? And few more stuff to add about O levels. Okay, now it is really close. So do things properly, okay? Do things properly in the sense like just before the exam, call one of your like trustable friend, okay? Just don't call someone just stupid as you. So just call some kind of a credible friend and confirm the dates and times of your exams. Okay, tomorrow we have it in the morning. Tomorrow, next day after tomorrow we have this subject in the evening, because every year there's a bunch of students coming late or coming before or coming in a different day to the exam. Okay, and at the same time confirm with your friend what to bring and what not to bring. Every year people forget some like admission papers, IDs. Then you come to the hall and start crying. It's a lot of trouble then. Okay, then you're not focusing on the exam. So one day before, confirm with your parents and confirm with your friends what to bring and what not to bring. Just don't in the morning, just don't start packing things up. Okay, then go at least 1 hour before to the exam, because there are accidents happening on the roads, different stuff happening, a lot of traffic. Okay, so just leave at least with a half an hour or 1 hour gap in the first day for sure. 1 hour, because you have to check your place, where are you going to be and all. Okay, and at the same time learn how to tie a knot using a small uh, like learn how to tie a knot. Okay, why? Otherwise some students can't tie their papers properly, then they waste 15 minutes for that. Okay, so at home learn how to tie your paper. Okay, you are getting a small piece of string to do that. Okay, so you all your life you have stapler things, now you all of a sudden you can't stapler. Now you are figuring out how to tie that for sometimes 15 minutes. Okay, so don't do that. Okay, things like this. Okay, be prepared and go. Okay, just don't waste time on these kind of useless stuff. Okay, if you're not prepared, you will definitely waste time on these kind of useless stuff. Okay, so moving forward, this application, there's a transistor here, there's a transistor here. So this is S, this is S, this is the bulb, there's a battery here, there's a battery here, then there's another 10 kilo ohm here to fulfill different purposes. Okay, to fulfill different stuff. So this is 10. So the idea is this. Okay, this we call a variable resistor. This is a variable resistor. Okay, so what do we do with a variable resistor? It decides how much voltage falls here, because you know that in this circuit this 3 volt is given to both the circuits. That means if this point is 0, this point is 3 volt. So that 3 volt is powering this circuit and that 3 volt is powering this circuit, both. Same 3 volts powering this circuit and this circuit both. But there's a variable resistor here. Okay, so when we rotate a variable resistor, okay, so in this circuit, what happens is this part decides the voltage. How? These are variable resistors. Okay, these are variable resistors. That means we can change the resistance here. So as you know, according to V equals IR, higher the resistance, higher the voltage, okay? Higher the resistance, higher the voltage. So the voltage felt here will increase when this resistance increases, will decrease when this resistance decreases, okay? Voltage felt here will increase when this resistance increases, will decrease when this resistance decreases. So compared to here, the voltage here goes up with resistance, So in that case, okay, what is the voltage here? This is voltage here means the voltage of the base. That means how much of food you have here. Voltage at the base means how much of food you have here. That means the positive potential at the base. They are calling electrons. That means how much food you have here. Based on that, how many students go to the auditorium will depend. So what happens is, when I increase the resistance here, focus here. When I increase the resistance here, okay, I can tune and increase the resistance here. More voltage will fall across this resistor. That means R is higher the R, higher the voltage. V equals IR. Then higher the voltage here, more current will flow in this circuit. If more current flow in this circuit, that means if more students come to eat food, more students will go to the auditorium. So more current will flow in this circuit. So higher the resistance here, higher the intensity of this bulb. Because higher the resistance, higher the voltage, more food, more electrons come to eat food, more students come to eat food, more are dragged to the auditorium. So higher the resistance, higher the current and voltage in this path. So higher the current and voltage in this path, higher the current in this path, So brighter the light here. So you increase the resistance, light gets brighter. You decrease the resistance, light gets dimmed. Clear? That is the idea. Did you understand that? Nice. So that is the idea. Okay. There are students asking how to study for exams and all. So these days what you should do is, for physics, yes, you have to focus a lot on physics because it holds a lot of marks. Okay, and that is the area where a lot of students lose marks. And you go through a short note, you can revise all the physics parts, okay? And go through few other short notes and all. Then you will revise other parts too. Okay, so if you can like revise things, everything fast, and do a few questions before exams, okay? Assume like maybe 10 questions from each category, ideally past papers and all. Then you can manage to get enough marks, okay? Clear? So try to, what you should do at this moment is, don't try to go through the entire textbook, okay? Don't try to go through the entire textbook, okay? So what you should do is like find some short notes. For physics, you have a short note. find some short notes, go through the short note, then try to quickly do few questions from each area. Then you will grow a certain confidence, okay? Then you will grow a certain confidence and do the last week's O-level paper again. Maybe last 3 years O-level papers again and properly check the answers. Then try to like understand those answers to a certain level. Then you have some experience on the theory. You have some experience on questions and you know what happened in last 3 years. If you know these 3 things, you can get a good mark, okay? Clear? In A-levels, you can't do that. A-levels is a much complex exam, okay? But in O-levels, you can like, yes, perform well. If you have a slightly good understanding about theory, if you have done some questions, and if you have an idea about what happened in last 3 years of papers, okay? So try to have that idea. Let's move forward. Now, this is the same circuit. This is the same circuit, but instead of a variable resistor, I'm talking about page 74. I'm talking about page 74. Instead of using a variable resistor, clear? Instead of using a variable resistor, we are using a LDR, light dependent resistor. We are using a light dependent resistor. We are using an LDR, light dependent resistor. Clear? So what happens with a light dependent resistor? It changes its resistance based on the amount of light that falls onto that. It changes its resistance based on the amount of light that falls onto that. Usually what happens is, when light falls to an LDR, so when light falls to an LDR, its resistance goes down. When it's dark, its resistance goes up. Its resistance goes up. When dark, its resistance goes up. So what is happening here is the exactly same thing. Why? When it is dark, in a light dependent resistor, resistance increases. So based on this explanation, when the resistance goes up, voltage goes up. That means voltage here will increase. When the voltage here increase, that means the more food on the table means more students to the auditorium. That means higher the voltage here, much stronger current will go through this circuit. That means this light will be very bright. This light will be very bright. But what happens when there's light? The resistance decreases. When resistance decreases, voltage decreases. When voltage decreases, that means less food on the table. That means less number of students in the auditorium. So when the voltage here goes down, current in this circuit also goes down. So the bulb will turn off. So the basic idea is, when dark, this bulb will turn on. When there is light, this bulb is turned off. That's what we need in a street lamp, right? In a street lamp, we need to turn it on when it is dark. When it is dark, resistance goes up, voltage goes up, more food, more current. So this light will turn on. When there is light, resistance goes down, voltage goes down, less food, less students in the auditorium. That means less current through this bulb. That means this bulb turns off. That's what we need to happen in a street lamp, right? Clear? Got the idea? Mention in the chat. Clear? Got the idea, students? Got the idea? I mean, I can teach the same theorem, same electronics at different levels, okay? Okay, I'm an electronic engineer, so I can explain this such that no one of you guys would understand, okay? So we don't use food and tables and auditoriums to explain electronics in the university, okay? I'm just using a method that you guys can understand, okay? Otherwise, these things are much complex than what I'm mentioning, okay? So if you like do science for A levels, you'll most probably meet us, okay? I'm doing physics for A levels, so you'll learn somewhat much complex electronics, the next level of electronics. Then if you are into engineering and if you go to do and be an electronics engineer, then you will learn a higher complexity of electronics, okay? So this is the simplest level of electronics we are learning at this moment, okay? That's why I'm using few familiar examples to make that more understandable. Clear? So in page 75, there's a part called for extra knowledge. In that page, what they are doing is, okay, explaining what is actually happening here. Okay, in that part, what they are telling is explaining what is actually happening here. That means let's forget everything else and think about this circuit, this part. Okay, so this side is 0. From this battery, this side is getting 3 volts. Clear? See, from this battery, this higher line, this upper line is getting 3 volts, and this is 0. So this is 0, this is 3 volts, okay? 0 and 3 volts, and there are 2 resistors here. So here in page 75, what they are doing is they are explaining what is actually happening. So let's call this resistor R1. Let's call that resistor R1, and let's call this resistor R2. Let's call this resistor R2. Okay, this is R1 and this is R2. And here we are giving 3 volts. Here we are giving 3 volts. Okay. Here we are giving 3 volts. So now what happens is this point is connected to the base, right? See, this point is connected to the base. That decides the voltage of the base. That means the amount of food that decides the voltage of the base. So now see, there's a current I going through this path. There's a current I going through this path. So if you can remember the equation V equals IR, this path is feeling a voltage difference of 3 volts, okay? This path from here to here is feeling a voltage difference of 3 volts. They are feeling a voltage difference of 3 volts from here to here. So the voltage difference is 3 volts. Current going through the circuit is I. Current going through the circuit is I. And the resistance from here to here is, total resistance from here to here is R1 and R2 both. Total resistance from here to here is R1 plus R2. Total resistance R1 plus R2. Then what is I? I is 3 over R1 plus R2, right? I is 3 over R1 plus R2. Okay, that is the current going through this path. Clear? That is the current going through this path. Now, as I mentioned, I need to find the voltage here. That means voltage gap across R2. I need the voltage gap across R2. Initially, I applied V equals IR from here to here. Initially, I applied V equals IR from here to here. Now I'm going to apply V equals IR from here to here. This voltage difference means the voltage felt by the base. This voltage difference means voltage felt by the base. So from here to here, when I apply V equals IR, this voltage difference is voltage felt by the base, VB, and current is I. Current is I, and this resistance is R2. Clear? And this resistance is R2. From here to here, the resistance is R2. Okay. So now VB is, what is I? What is the current? This is the current going through this path, right? This is the current going through this path, which is 3 over R1 plus R2. 3 over R1 plus R2 into R2. Clear? 3 over R1 plus R2 into R2. That's what they are mentioning, okay? That's what they are mentioning. Clear? So, they have, in that page 75, they have given us the values. They are telling us to find. So, next, they are asking, if R equals 10 kilo ohm, find R2 in order that V equals 0.7 volts. That means they are asking to make VB 0.7. To make VB 0.7. In that page 75, after deriving this equation, they are asking to make VB 0.7. What should be the value of R2? Given that, focus here, given that R1 is 10 kilo ohm. What is 10 kilo ohm? 10 kilo ohm means 10,000 ohms, right? 10 kilo ohms means 10,000 ohms into R2. So VB is 0.7. To make VB 0.7, what should be the value of R2? So I'm going to keep R2 as R2 because I have to find that. When R1 is 10 kilo ohms, that means 10,000 ohms. You solve this. How can you solve this? Cross multiply. Keeping 0.7 here, you are going to cross multiply and bring this guy up. 10,000 plus R2. 10,000 plus R2. You bring this guy to this side, equals 3R2. Equals 3R2. Then 0.7 into 10,000. Focus here. 0.7 into 10,000. Plus 0.7 into R2. 0.7 into R2 equals 3R2. Equals 3R2. 0.7 into 10,000 gives me 7,000. 0.7 into 10,000. 0.7 into 10,000 gives me 7,000. Gives me 7,000. plus 0.7 R2 equals 3 R2. Then 7,000 equals, I'll take this one to that side, 3 R2 minus 0.7 R2, which means 2.3 R2, 7,000. Then R2 equals 3 minus 0.7 is 2.3, 7,000 over 2.3. 7,000 over 2.3, which gives me 3043 ohms. 3043 ohms. That's how the calculation is done. Okay. Many students mentioned that this part is hard. So this is the idea. That's how the calculation is done. Clear? They are deciding what is happening in a certain path. Clear? They are deciding what is happening in a certain path. Clear? Zoom to this whole part from here to, from this area to this area. Just mention. Did you understand what is happening there? Many students mentioned that this part is difficult to understand. That's what actually happens. Clear? Did you understand? It's just applying V equals IR to two circuits, okay? Applying V equals IR to two circuits. I'll repeat once more, since some students are asking. Initially, this voltage is 3 volt and this voltage is 0, okay? And from here to here, there's a total resistance of R1 plus R2. So voltage difference from here to here is 3 volts. Current going in the path is I. Total resistance in the path is R1 plus R2. Then I get the current. So this is V equals IR. Then the current is I equals 3 over R1 plus R2. I equals 3 over R1 plus R2. So that is the current going through this path. Now they are asking VB. VB means actually the voltage difference across R2. It is the voltage difference across R2. So to find the voltage difference across R2, I'm going to apply V equals IR to R2 only. Then voltage difference across R2 is VB equals current I is 3 over R1 plus R2. Current I is 3 over R1 plus R2 into, here current is 3 over R1 plus R2, that same current going through R2, into IR. R is R2 because I'm searching for the voltage of R2. So that is the equation. This is how we get VB. Then they're asking to make VB 0.7, what should be the value of R2? What should be the value of R2 to make VB 0.7, given that R1 is 10 kilo ohms. 10 kilo ohms means 10 into 1000 ohms. That means 10,000 ohms. Then we solve, okay? I bring this here, cross multiply, focus here. 0.7 into 10,000 plus R2. Then in this side you have 3 into R2. This side you have 3 into R2. Then here it is 0.7 into 10,000 plus 0.7 into R2 equals 3R2. Then 0.7 into 10,000 is 7,000 plus 0.7 R2 equals 3 R2. Here 3 R2. Here 3 R2. Here 3 R2. Minus 0.7 R2 equals 7,000. 3 minus 0.7 is 2.3 R2. Here you have 7,000. Then R2 is 7,000 over 2.3. That means 3043 ohms. Clear? That's how it functions. Did you understand the concept? Now let me know. So this is that circuit, okay? This is that circuit we explained. This is that battery. This is that battery. This is that LED. This is that LED. This is the transistor connecting them. Can you see? This is the transistor connecting them. And this is that variable resistor. See? These variable resistors are rotatable, okay? These are rotatable variable resistors. That means when you rotate these, see? Intensity changes. Clear? When you rotate this, intensity changes. See? Clear? When we rotate it, intensity increases. When we rotate it in the other direction, intensity decreases. See? Based on the rotation, intensity changes. Why? Why? When I rotate it, voltage increases. When voltage increases, when I rotate it, resistance increases. When the resistance increases, voltage increases. When the voltage increases, intensity of the bulb increases. When I rotate in the other direction, resistance decreases. When the resistance decreases, voltage decreases. When the voltage decreases, intensity of the bulb decreases. Now, this is the variable resistor. See, this is a variable resistor. So these are actually rotatable, okay? See, these are actually rotatable. It says a value here. That is the value of that variable resistor. Maximum value is 10 kilo ohm. See, this is a 10 kilo ohm variable resistor. Maximum value is 10 kilo ohm. That means when I rotate it fully, it gives me 10 kilo ohms. When I rotate in the other side, it gives me 0. Then this is a transistor. This is a transistor. See, there are two sides for a transistor. Base, emitter, collector. Base, emitter, collector. This is a transistor. Clear? And this is the LED. Clear? This is the LED. One side has a higher length. Other side is shorter. We connect the positive terminal to the lengthy side, negative terminal to the other side. So that's how these things actually functions. Okay. So electronics applications part is over. Hope you understood that. Okay. Hope you understood that. So now since let's do few questions. Okay. Let's do few questions from the book. Okay. Let's do few questions from the book in the remaining time. Since we discussed electronics, I'll go into electromagnetics questions kind of stuff. That means in our book, we discussed until page 45, okay? We discussed the questions until page 45 as I remember. So we have to move forward from that point, okay? We did a question discussion last week, 3-hour question discussion. We did until the 45th page of our book. Now we have to move forward from that point. So let's move to our book, okay? Now the book is anyways available in the group. It will be available in the group, in the Zoom chat, under resources. In the webinar, under your webinar, you can see a icon called resources. Go there, you can find the tute, and it will be available in the YouTube live chat too. Okay, in the description of the YouTube live chat, you can find the tute, and again, they are available in the groups. We are providing it again in the groups now, and it is available in the channel too. Let's go to the book and do a few questions. But today's main target was this, and I think I did a good job at explaining this part, okay? Because I mean, our job should be, we are not O-level teachers. I'm an A-level teacher. My target is actually teaching things that you struggle to understand, okay? That should be my target. Otherwise, you had enough O-level teachers to explain everything in O-level. So throughout these sessions, we did close to 10 sessions, okay? Throughout these sessions, what I tried to do was explaining things that you struggle, okay? Not the easy parts, okay? I mean, I could have done the easier parts and get very good comments from you guys. Okay, everything is understandable, but I didn't do that. I didn't explain the easier parts. I always try to explain the more difficult parts in the syllabus so that you won't struggle, okay? And that is a challenge for me too. Because anyways, when we try to teach difficult parts, there's a high tendency that you are not understanding that and we are getting a bad name. But still, I think I managed to explain things well. And that was my target actually. I mean, getting you out of the trouble if you are struggling to understand anything, okay? That's why I didn't focus on easier parts in the syllabus. That's why I always focused on the difficult parts that you continuously requested, okay? So let's move forward. You can like maybe have a walk for 1 minute, okay, until I erase the board, jump a bit, drink some water, okay? You need some like, I mean, otherwise we can't sit there for 2 hours, okay? Then let's move for questions. Hope you got the book, okay? I also got it to my mobile phone. Let's do the electromagnetics and electronics questions quickly. Quite relatable stuff. Let's finish because they are related to this lesson. So, I'm just going to go through the important questions. Page 87. Page 87. Question number 1. Page 87. Question number 1. According to the input and the output, what is the suitable circuit which should be found in the box? What should be the suitable circuit in the box? So this is rectification. And based on this, hope you can remember, this is rectification. This is rectification, and it is a full wave rectification because both the positive part and negative part is rectified. So this is a full wave rectification. What is this? This is a half wave rectification. If only the positive part pass, and if the negative part doesn't pass, it's a half wave rectification. This is a full wave rectification. Okay. So in this full wave rectification, what is the full wave rectification circuit? This. Just remember, all the diodes go in the same direction. Okay. In full wave rectification, all the diodes go in the same direction, aim into the same direction, like this, like this, like this, then like this. All the diodes go aim in the same direction. Okay. Then we give the input here and here. We give the output here. Okay. So this is the rectification circuit. And now I have to figure out whether there's a capacitor here or not. There shouldn't be a capacitor here. Why? This circuit gives me this output. If you can remember, this circuit gives me this output. But if I connect a capacitor, it tries to make this much linear like this. Can you remember? It tries to make it much linear like this. Clear? That is the whole point of using a capacitor. We use a capacitor to go from here to here. So in this example, they haven't given me this, they are giving me this. That means we don't have the capacitor connected. Okay. We don't have the capacitor connected. So the answer should be 3. Okay. Answer should be 3. Clear? P is too much for you guys. Let's go to question 3. Let's go to question 3 in page 88. Page 88, question 3. Page 88, question 3. A circuit given below demonstrate a certain process of an electric circuit. Name A, B, and C. A, B, and C. What is the change that you expect to happen in B1 and B2 in the circuit if a switch is closed and both LEDs are illuminated? What function does the above circuit demonstrate when a switch is opened? B2 LED extinguishes. Explain the reason. Okay. I'll quickly move to electromagnetics questions. Okay. So the idea is this. There's a circuit like this. So this is the circuit. This is B1. This is B2. This is A. This is C. So they are asking what is A, B, and C. A is the transistor. A is the transistor. B are LEDs. B are LEDs. C is a variable resistor, okay? This symbol is used to represent variable resistors. C is a variable resistor. What is the change that you expect to happen B1 and B2 in circuit if S switch is closed? So what is the change? Actually, they are asking the property. So if you close this circuit and if these two bulbs turn on, the change that you are seeing is the B2 bulb is brighter than B2 bulb is brighter than B1, because this is going to the base. More current goes through the emitter always. Can you remember? More current goes through the collector emitter circuit always. Low current goes through the base. According to that pattern, more current goes through this path, right? Always low current goes through this path, more current goes through this path. So B2 is brighter than B1. B2 is brighter than B1. Then 3, what function does the above circuit demonstrate? I can call amplification and switching. I can call amplification and switching. When I turn on and off this switching circuit, I can see what is happening, who turns on and who turns off. That is the switching nature, and mainly the amplification nature. Why? When this one has a lower brightness, this one has a higher brightness. When this one has a lower brightness, this one has a higher brightness. So it shows the amplification. Lower brightness provides this higher brightness. Same proportionality. But this one is brighter than this one. Here, so what is the function this circuit demonstrates? It is the amplification nature. When S switch, fourth one, when S switch is open, B2 LED extinguishers. Now I turn on this switch is open means turn off. I off this switch. Then what happens? When I off this switch, the base current stops. That means no food. If there is no food, no students in the auditorium, no current in this path. So you can tell base current stops when we open this switch, which makes the collector current stop. Clear? If the current in this path stops, current in this path stops. Why? If you remove the table of food, no one's gonna enter to the auditorium. Okay? Clear? Let's go to question 4. The question after this. In the same page 88. Question 4. A silicon diode with forward voltage drop of 0.7 volt is connected in series with 1 kilo ohm resistor and a 9 volt DC power supply. In a forward bias configuration, draw the circuit diagram for this setup. Calculate the voltage across the 1 kilo ohm resistor. Calculate the current flowing through the circuit. Okay, we'll see. Okay. Question 4. A silicon diode This is a silicon diode with a forward voltage drop of 0.7 volts. That means for this diode to work, we need to provide 0.7 volts is connected in series with 1 kilo ohm resistor. It is connected with a 1 kilo ohm resistor. And a 9 volt DC power supply. I'm connecting a DC power supply of 9 volts to a 9 volt DC power supply in a forward bias configuration. Draw the circuit diagram for this setup. This is the circuit. 9 volt bulb, 9 volt battery in a way that this is forward biased. 0.7 volt voltage drop and the diode and a 1 kilo ohm resistor. Draw the circuit diagram. Done. First part done. Calculate the voltage across the 1 kilo ohm resistor. So this is the idea. This battery is providing us 9 volts. And from that 9 volts, the diode keeps 0.7 volts. From that 9 volts, the diode keeps 0.7 volts. So the remaining part will be kept by this 1 kilo ohm, okay? Remaining part will be kept by this 1 kilo ohm. What is that? Remaining part is battery is giving 9 and the diode is keeping 0.7. So the remaining voltage would be taken by the resistor, right? If the battery is giving 9, if the diode is taking 0.7, this one should get the remaining part, which is 9 minus 0.7. So the voltage across 1 kilo ohm is 9 minus 0.7. It is 9 minus 0.7, which is 8.3 volts. It is 8.3 volts. Clear? So 1 kilo ohm resistor is receiving 8.3 volts. Calculate the current through the resistor. So how can I calculate the current through that resistor? Quite easy. There's a 1 kilo ohm resistor. 1 kilo ohm means 1000 ohms. 1 kilo ohms means 1000 ohms. And it's getting 8.3 volts of voltage. It's getting 8.3 volts of voltage. Then if I apply V equals IR to this guy, voltage is 8.3. The resistor is receiving a voltage of 8.3. Current I, what is the resistance? It is 1000 ohms. Resistance is 1000 ohms. So what is the current? It is 8.3 over 1000, which means 8.3 into 10 to the power minus 3. 8.3 into 10 to the power minus 3. I'll take this up. 10 to the power minus 3 amperes. Clear? That's how it functions. Or I can just keep it as 8.3 over 1000 amperes, which is equal to 0.0083 amperes. 0.0083 amperes. Usually diodes are made out of silicon, okay? That's why we always use that silicon diode term. And if they talk about a silicon diode, usually the voltage difference across the diode becomes 0.7, okay? There's a rule about, that is a rule about silicon diodes. The silicon diodes, potential difference usually is 0.7. Okay, potential difference of a silicon diode is usually 0.7. Let's go to some electromagnetics questions. Go to page 77 to revise the content a bit. Go to page 77, and I did an entire session about electromagnetics. Okay, so you can refer to all these sessions. Okay, I did an entire session about electromagnetics too. So whatever the parts you usually find hard, we have done. Okay, so page 77. Let's go to question 2. Question 2, page 77. Question 2. Figure shows a magnetic field around a current carrying conductor. Figure 2 shows a movable conductor placed in a magnetic field. What is the direction in which the current should flow through the wire to form a magnetic field shown in figure I? Which rule do you use to determine the direction of the current in figure 1 above? Then in figure 2, what is the direction of the current flow when switch is closed? What is the direction of the movement of AB rod based on X and Y? Write down 2 strategies that can be used to increase the speed of motion of AB. Okay, let's try the question. Question 2. There's a current wire. I usually do electronics and electromagnetics together because they are very related. So there's a current I. The direction of current should be this, to have a magnetic field in this direction, right? That is the first question. What is the direction of current? It should be this. Why? Can you remember what is the law mentioned in the chat? If the magnetic field is like this, see, it's right hand law or Maxwell's corkscrew law, which tells, okay, I'll use the right hand law. The thumb shows the direction of current. Can you remember? The thumb shows the direction of current. Then the other fingers shows the direction of magnetic field. Can you remember? The thumb shows the direction of current. Then the other fingers shows the direction of magnetic field. Then B, which rule do you use to determine the direction of current in figure 1 above? What is the rule we are using? Which rule do you use to determine the direction of current? Maxwell's corkscrew law or the right hand grip rule. These things you know. So part A and B is done. Next question. Part 2. There's a magnetic field like this. There's a north, and there's a south like this. Okay. Then from here, 2 wires go like this. Okay. Then we have kept a conductor like this. Okay. We have placed a conductor like this. And there's a battery connected like this. There's a battery connected like this. So when I turn on the switch, in which direction of the current flow when switch is closed? Current will go in this direction. Okay, sorry for the disturbance. We'll move forward. You can hear us clearly, right? So now, what is the direction of current flow? You can call it from B to A. This point is called B. This is called A. So you can call current goes from B to A. Current goes like this, then like this. So current goes from B to A. Here you can tell current goes from B to A. Then, what is the direction of movement of AB rod based on XY? A is okay. Current goes from B to A in this direction because the battery's positive terminal is in this direction. Then B, what is the direction of the movement of AB based on X and Y? What is the rule? Fleming's left-hand rule. Fleming's left-hand rule. Current is represented by the middle finger. Current is represented by the middle finger. Magnetic field is represented by the index finger. So the current is going like this. So the current is going like this. Magnetic field is going like this from north to south. From north to south. So current going like this. Magnetic field going down from north to south. Magnetic field going down from north to south. Current going like this. Current going like this. Then thumb shows the direction of motion. This is the direction of motion. So this is going to move in this direction. That means from X to Y. It's going to move from X to Y. Then C, write down two strategies that can be used to increase the speed of the motion. So we know that this speed is dependent by the power of the magnet. So we can use a much powerful magnet for this. I can use a much powerful magnet for this. Then I can use a much powerful current for this. I can use a much powerful magnetic field. Okay. I can use a much powerful magnetic field. I can use a much powerful magnetic field. And I can use a much powerful current. Increase the current or use a powerful magnet. Then the force will increase, then this will move faster. Okay. Clear? Left hand rule is used to find the direction of motion. Okay. Right hand rule is used to find the electromagnetic induction direction. Direction of the induced electromotive force. Right hand rule is used for that. Left hand rule is used to find the force on a conductor in a magnetic field. Okay, that's the difference between left hand rule and right hand rule. Let's go to question 3. Let's go to question 3. Malik. Let's go to question 3. Page 78. Page 78, question 3. Okay. So, page 78, question 3. What type of transformer is shown in figure 1? If the number of turns in the primary coil and the secondary coil of that transformer are 1000 and 100, respectively, find the output voltage at the end of CD. Write the use of transformer in figure 2. Okay. Okay. So question 3. Part 1. So there's more loops in this side, less number of loops in this side. That means it is a step down. Voltage is decreased from here to here, right? Voltage is decreased from here to here. So it is a step down transformer. Step down transformer. Voltage decreases from here to here. මෙහෙට යද්දි voltage එක අඩු වෙනවා. Voltage decreases as it is step down. The number of turns in the primary coil and the secondary coil of that transformer 1000 and 100. This side is 1000. This side is 100. Find the output voltage at CD. They need VCD. They are giving 230 volt to this side. So you know this, right? What is the transform equation? V primary over V secondary equals N primary over N secondary. So V primary is voltage given to the primary. Voltage given to the primary, which is 230. Then what is V secondary? It is this. Voltage in the secondary is VCD equals N primary is 1000, N secondary is 100. N secondary is 100. 1000 and 100. Then these zeros cancel out. VCD and this 0 and this 0 cancels out. Then VCD I take here. So VCD equals 23 volts. 23 volts. VCD equals what? It is equal to 23 volts. 23 volts. Then what? Write the use of transformer shown in figure 2. So in figure 2, question 3, we have a transformer like this. Less number of loops in this side, higher number of loops in this side. Okay, so what is this? This is a step up. This is a step up transformer. Okay, this is a step up transformer. That means the voltage is increasing from here to here. Voltage is increasing. It is a step up transformer. So what is the use case? Use case, increase in the voltage. Increase in the voltage. That is the main use case of that. Increase in the voltage. Clear? Use case of a step up transformer is increase in the voltage. Okay. I just did few questions to revise you the content, and based on the request we'll be doing more sessions, but it entirely depends on what you need and what you don't need. Okay. So I think until today we have done like close to 10 sessions. We did sessions at different schools too, based on requests. Today morning also we did a practical seminar, our team. Okay, so I think you found that beneficial, and we'll be doing stuff if you need. Okay, so but another thing is, in all level exams, a lot of students, they think that this is really important. Due to that stress, they tend to stay in one question. If the question is hard, they tend to stay in that question and somehow finish it without leaving the question. You should have proper mentality when you are going to exam. If a question is hard, leave that. Quickly finish the remaining parts, then return to that part. Okay, keep that in mind. This is one of the main mistakes students do. They stay in the difficult question. No, you should leave the difficult question, quickly finish everything, then return. Okay, then then you should return to the difficult question like this. Like, properly manage the time. Okay, it's not about the subject actually in the exam. How many marks you are getting is actually based on your time management. Okay, your management skills. So keep them right, keep your mental clarity. Okay, so you can find all the resources in our group, in our channel, in our YouTube channel, and in our WhatsApp channel. Everything is properly organized. If you have any issues, you can send a message to our number. Okay, not 1546825. Not 1546825. We'll keep providing resources based on your requests. Okay, and we'll be meeting again most probably if you are doing that's or bio for A levels. Hope to meet you guys. Yeah, so thank you for joining today. And all the other resources will be again available in the groups. Okay, and if this is the last session that if you are joining, good luck with your exams. Okay, thank you.